We're now going to look at our last section, lesson 310, titled All Systems Go. This is solving problems with systems of equations. You're welcome to read any of the intro stuff. We're not going to summarize Polya's problem-solving strategy again. You can look through that. We've done it a few times, so you can look back or look at the old videos where we did that. We're going to start towards the bottom of page 425. The paragraph that starts with the word when. When we're studying a situation with two variable quantities, we may be able to set up what's called a system of equations. This is two or more related equations that share a common variables. Let's start off with a situation that might lead to a system of equations. The shipping manager at a small business sent out a shipment of 3 coffee mugs and 6 promotional packets on Monday. So I'm going to underline that information because we might need that. 3 coffee mugs, 6 promotional packets. On Monday, the weight was 42 ounces. Let's read the next sentence to see what other information they give us. On Wednesday, she sent out 6 more mugs and 3 more packages, and this time the weight was 48 ounces. I'm going to need all that information. Now the boss wants to know the shipping weight for each packet and for each mug. Our goal is to help the shipping manager out. Go back to my red pen. We're going to scroll down here. Number 2 on page 426 says, in this problem, there are 2 variable quantities that we don't know, the shipping weight of a packet and the shipping weight of a mug. If we use X to represent the weight of one mug and Y to represent the weight of one packet, write an expression that describes the combined weight of 3 mugs and 6 packets. This is the part that I underlined in red up there. So I know that 3 coffee mugs is going to be 3 times X. I'm going to add that to the weight of the packets. I have 6 promotional packets at Y ounces each. So 3X plus 6Y should represent the weight of 3 mugs and 6 packets. Number 3 then says, let's take that expression that we just wrote, 3X plus 6Y equals the total that they gave us in the problem. Underlined in red above in the paragraph, we know that the total was 42 ounces. This gives us our first equation. The author lets us not go through the second equation and does it for us. The part underlined in purple gives us 6x plus 3y equals 48. Now they ask us to solve each equation for y. So let's start with the first one. I have 3x plus 6y equals 42. When I'm solving an equation with variables in terms of another variable, this is called formula rearrangement. And that's what we'll be doing here. Scroll down to get myself some room to work. So how do I get y alone in this first equation? I need to first subtract the 3x from both sides. So now I have 6y equals, the standard is to write the x part first. It's okay to write negative 3x plus 42. That's the more standard way. It would also be okay to write 42 minus 3x. One more step to get y alone is to divide both sides by 6. So my equation now is y equals, let's reduce the negative 3 over 6. You can do it in the calculator or by hand. That's negative 1/2 x plus, what's 42 divided by 6? 7. Let's go ahead and do the same thing for our purple equation. I have more room to write this. We have 6x plus 3y equals 48. How do I solve this for y? My first step is to subtract 6x from both sides. So I have 3y equals, again, the standard notation is to put the negative 6x first. Last step then is to divide everything by 3. Y equals negative 2x, oops, not 6, See if my eraser will work for me. It did. 48 divided by 3 is what? 16. So these are my two equations that I'm going to work with. They now ask us in number 5 to make a table of values for each equation. You could type this into your calculator and make your calculator do it. So for the first one, you could type in for y equals negative 1/2 x plus 7, and force your calculator to create the table. If I'm going to do it by hand, I'm replacing each x with the number given. So I start out replacing x with 2. Negative 1/2 times 2 is negative 1, plus 7 is 6. Continue likewise to fill in the rest of the chart. So we have 6, 5, 4, 3. You can usually pick up a pattern. I would always verify them, double check using my calculator. For the purple side, I am going to take negative 2 times 2, which is negative 4, plus 16, which is 12. And I thought I switched to purple, but it apparently did not switch for me. Do negative 2 times 4, which is negative 8, plus 16, which is 8. Again, you could type this into your calculator and force your calculator to do the table like we did in section 3.6. Refer back to that video to see how to do this. I'm going to continue to fill in the chart. And that is what your table should look like. We're now going to graph both of these on the same coordinate axis. Again, you can do this on your calculator. We showed you how to graph. You could graph both of them, putting one in as the first y, the purple in as the second y, and graph them on the same coordinate axes. I am going to graph both my equations. I'm going to give you a rough estimate here. So the red one should look something like this. And I'm really bad at drawing very straight lines. The purple one, if I use my slope and my y-intercept, the purple one is way up there, so I can't get there, so I'm actually going to back it and use my chart. What are some of my points for my chart? I have 3, 0. That's a nice one to graph. Not 3, 0. I have bifocals. I can't see. 8, 0, which is a nice one to graph. So I can have a point here. What's one other point for my purple list? I could do 6, 4. So over 6, up 4. And then connect my purple ones. So they look something like this. Number 7 asks, where does it look like the two lines intersect? It appears that the two lines intersect at the point 6, 4. Right there. Let's plug those into both equations and see what happens. So my red equation was originally 3 times x plus 6 times y equals 42. Put my green answer in and see how this works. In place of x, I'm putting 6. In place of y, I'm putting 4. That's coming from the point we found up here. First value is x, second value is y. I get 18 plus 24 equals 42. Does that work? Yes, 18 plus 24 is indeed 42. So it does work into the first equation. Next, we need to try it into the second equation. My purple equation originally looked like 6x plus 3y equals 48. I'm going to put my green intersection point in again. 6 for x, 4 for y. I get 36 plus 12. Does that equal 48? It does indeed, so our solution is correct. Number 9 says, what does this solution tell us we found? Well, what we just found is that mugs weigh how much? 6 ounces. And how much does each packet weigh? 4 ounces. Turning the page to page 428, we're going to continue with our work with systems of equations. They ask, how do you think you could have found the solution to the system from the table you made without graphing? So let's look back at our table and see what we notice. I notice from my table that when I plug 6 in to both equations, I get 4 out. So by looking at my table, I can say that the solution is clearly 6, 4. You could also do this on your calculator if you plug both equations in and look at your table. So our next goal will be to develop an algebraic method for solving a system of equations. Write the result earlier we got when we solved the second equation for y. So we got, this was our purple one. Let's go back and see what we got. Way back up here. I got y equals negative 2x plus 16. Now they say go back to our red equation, our original first equation, and our original first equation was 3x, that was my red one, didn't change my color for me, 3x plus 6y equals 42. X is going to stay in x, but in place of y, I'm going to put what we just found y to be equal to. Y was equal to this, so it's going to be 6 times negative 2x plus 16. And I wrote really small there, sorry about that. And then we solve that equation. I would solve that equation by distributing through. So I get 3x minus 12x plus 96 equals 42. This is actually the work that they're asking us to do in 12, so we'll just continue down here below 12. Combine my like terms, negative 9x plus 96 equals 42. Subtract 96 from both sides. We get negative 9x equals negative 54. One last step to solve that. We divide both sides by negative 9. And x is 6, which matches what we previously found. You then would plug 6 back in up here. Negative 2 times 6 plus 16. Negative 12 plus 16. We do indeed get 4. So we got the same solution. We got the solution of 6, 4. So rather than doing it graphically or by the table, we're able to do it algebraically. The steps are listed here. You can certainly follow that and read through that. And I'm trying to see how much time we have. I think we're going to skip the next example, and I think at this point you should be ready to do the group work that continues your work with systems of equations.